Thank you very much, Frank. It's a pleasure to be here. Let me just see if I can figure out where to put this. And so, to tell this story about where we stand today in the modernization of U.S. nuclear forces, we have to go back about 10 years to the Obama administration. And the framework for the Obama administration's nuclear policy was laid out in a speech in Prague. Some of you may remember it. A huge crowd. He identified the continued existence of thousands of nuclear weapons as not just the most dangerous legacy of the Cold War, but one of the most pressing threats to civilization. And he had been focused on this issue also as a senator. And this was at the top of his list of priorities as president to make some fundamental changes in American policy. And he laid out the framework in this speech. And we would often say that there were 4 pillars to the speech. I'm just going to mention the first 2. The first was reducing the role of nuclear weapons in our national security strategy and urging others to do the same. And the president specifically committed to negotiate a new arms control treaty, an arms reduction treaty with Russia, which is the treaty that is in place today, the New START Treaty. And then to review U.S. nuclear strategy to pave the way for further reductions that would include ultimately all nuclear weapons, not just strategic nuclear weapons that are deployed, but also non-deployed weapons and tactical nuclear weapons, and then in the longer term, all nuclear weapon states. So that was the agenda. That's the first pillar. The second pillar was, while nuclear weapons exist, so long as nuclear weapons exist, to maintain a safe, secure, and reliable U.S. nuclear arsenal. The other 2 pillars of the Prague framework had to do with strengthening the non-proliferation regime and bringing Iran and North Korea back into compliance with that regime. And then the final pillar was preventing nuclear terrorism. And a major focus there was securing vulnerable nuclear materials. And there were 4 nuclear security summits that led to the removal of over 4,000 kilograms of high-enriched uranium from 31 countries, and the complete removal of high-enriched uranium from 31 countries. But just to focus now on the reductions, so the administration conducted a review of nuclear policy, the 2010 Nuclear Posture Review. As a result of that, the New START Treaty was negotiated with Russia that led to a 1/3 reduction in deployed, strategic, accountable nuclear warheads. So the limit of the New START Treaty is 1,550 deployed, strategic, accountable warheads. But because of to ratify a treaty in the U.S. Senate, you need 2/3 approval of the Senate. And that is a very high barrier today. I mean, I'll challenge any of you to think of anything that 2/3 of today's Senate would agree to. And it was very difficult in 2010 also. New START did pass. It was ratified with 71 votes, but a condition of ratification was a pledge by the administration to modernize all 3 legs of the nuclear triad, and I'll talk in more detail about that. There was also then after the treaty, there began a comprehensive review of U.S. nuclear strategy called employment policy. And that was completed at the end of 2012, and in the beginning of 2013, the president gave a speech in Berlin where he announced that we could reduce our nuclear arsenal even further by another 1/3, down to about 1,000 deployed strategic weapons. And he invited President Putin to open negotiations. And as you know, that never happened. That never happened because, largely because, well, 2 reasons. First, Putin was not very interested in further reductions, claiming concerns about U.S. ballistic missile defenses and the threat that they posed to the Russian strategic deterrent. But also there was the invasion of Crimea and Ukraine. And after that point, it was impossible to enter into any kind of negotiation with Russia. When we talk about the plan today and the Trump nuclear posture review, which was completed last year, and the plans for modernization in the current administration, they are really almost the same as the Obama administration. The differences are actually pretty minor. I think they're important, but they're not major expenditures. So the framework for the modernization program was laid out in the Obama administration to replace all three legs of the triad, ICBMs, submarines and the SSBNs on them, and bombers. And because we were unable to enter into a negotiation on a treaty that would reduce force levels further, this modernization program is sized to the current force level, to the New START level, to that 1550 level. The hope was we would by now have a new treaty that would have reduced the agreed force levels to 1,000, and that would have resulted in a smaller modernization. And these modernization programs, as you will see, the weapons will be fielded in the 2030s, and they will have lifetimes of 50 or 60 years. So this modernization that we're embarking on will allow the United States to maintain the current deployed force almost to the end of the century, well into the 2080s, which was a little in tension with President Obama's vision in the Prague speech to work toward a world free of nuclear weapons. I know he said, perhaps not in my lifetime, but he was probably thinking before 2100. There's also what I'll talk about are the delivery vehicles, the strategic nuclear delivery vehicles. I won't talk about the elements of this modernization that relate to warheads and the production complex. The next speaker will do that. So this is what the triad looks like today. There are 400 Minuteman 3 ICBMs that are deployed in 400 silos in North Dakota and Montana and Wyoming and Nebraska, and I forgot a state, South Dakota. There are 14 Ohio-class Trident submarines, of which 12 are operational at any one time. Oh, I should have said the ICBMs carry one warhead each. So 400 missiles in 400 silos with 400 warheads, although the Minuteman can be uploaded to deliver 3 warheads each. So we do have reserve warheads ready to be redeployed on Minuteman to increase that force if necessary. Then there are the 14 submarines, the 12 that are operational at any one time. Each of those submarines is now equipped with 20 submarine-launched ballistic missiles, SSBNs, so 240, 12 times 20, 240 missiles. Each missile can carry 8 warheads. On average, it's 4 or 5 now. And then the B-52 bombers, which are still flying, there are 42 of those that can be deployed, and 18 B-2 bombers that can be deployed that can, both of these platforms can deliver bombs. The B-52 can also deliver nuclear-armed air-launched cruise missiles. So that's the force today, and every one of those platforms is reaching the end of its lifetime, according to DoD. I'll talk a little bit about the ICBM in particular at the end. And this bill is coming due for this modernization of all 3 legs at the same time. And this is what the bill looks like. Sometimes it's referred to as over $1 trillion or 1.2 trillion. The new hardware is about $400 billion, and this is over about a 30-year period. So 12 new submarines for about $165 billion. And I should emphasize that these are the current estimates, and as we all know, defense programs tend to end up costing more and taking longer than is originally estimated. There's some like universal inflation factor you should probably apply to all of these numbers of maybe 30%. 400 new ICBMs, and that system is called the Ground-Based Strategic Deterrent, or GBSD. And just the cost of the missiles is $75 million, billion dollars, but there are also large other costs associated with modernizing the silos and refurbishing the silos and the command and control systems. And then 100 new long-range strategic bombers that would mostly, it is thought, have a conventional role, but would also have a nuclear mission. And those cost $130 billion. And then a new cruise missile for the bomber, and that cruise missile would cost $20 billion. So you add it all up, it's about $390 billion. And then you have the operation and sustainment of those forces, and the nuclear command and control system, and the nuclear weapon production complex. That totals, those are just the sort of ongoing costs of about $850 billion. So in all, about $1.2 trillion. And this is what the spending profile looks like over time. This is from a Congressional Budget Office report. And you see that, let's see, here is the pointer. Oh, you can't really, oh, there it is. So just the operation of that force that I showed before was about $22 billion a year. And this modernization will peak at about $22 billion a year of expenditure. So it roughly doubles the cost of the DoD budget for nuclear forces. Now, DoD is quick to say, but it's only 6% of the defense budget. And of course, that's true because the defense budget, the denominator, is such an enormous number that even $50 billion a year is a fairly small percentage. But I think by anyone's standards, $50 billion a year or $22 billion a year for the peak spending on the modernization it's a lot of money. And it's probably worth thinking hard about whether you really need all of this and if there are ways of saving money, of reducing that cost. Now, I think almost everyone would agree with the need to replace the submarine force because the submarines are the most survivable leg of the triad. When submarines are at sea, they are not vulnerable to detection or attack. And the Navy is quite confident about this, and that was recently expressed in the Trump NPR. And at any one time, we might have 8 of those at sea, and each one of those submarines might have up to 100 warheads, on that order. So that is a very potent retaliatory force. Also, submarines have the advantage that they can move around. So they can launch from any point in the ocean. And so they could be used if there was a situation in which you did not want to overfly Russia. Because Russia was not the target, you can accomplish that with submarines. Of course, the disadvantages are that if you ever do figure out how to find submarines at sea, there would not be very many to find. There would be 6 or 8. And once you find a submarine, they are not hard to destroy. And so people do raise, in fact, the other legs of the triad are all often justified in terms of a hedge against the vulnerability of submarines. And this has been true now for many decades, and still no one has identified a plausible way that you can find these very quiet submarines at sea. Bombers have the virtue that they can be dispersed. They can be used for signaling in a crisis and have been. You can have bombers fly to Diego Garcia or Korea in a crisis to signal resolve. They are not survivable against a surprise attack because it takes about a day or 2 to get them ready to fly. And so they are vulnerable to a bolt out of the blue attack, but we think a bolt out of the blue attack is extraordinarily unlikely, that there would be warning, there would be a crisis that would precede any conflict. They can deliver weapons with a wide range of yields. They can deliver bombs, and the bomb in the stockpile, the B-61 bomb has various yield options, including very low yields. Also, they can deliver cruise missiles that can penetrate an air defense better than a manned aircraft, and those cruise missiles also carry warheads with lower yield options. And yes, and there's a relatively low cost relative to the cost of the bomber to add a nuclear option to a bomber. So I showed on the earlier slide, what was it, about $160 billion to build the 100 B-21 bombers. Probably 15% of that cost is associated with the nuclear mission. Now, one thing, though, I never could get a good answer from the Air Force is if you need 100 for the conventional and nuclear mission, what if they didn't have a nuclear mission? How many would you need? And the answer was 100. And I always found that to be really puzzling. Like, how can, if B is non-zero, how can A plus B be equal to A? But that was the math. The disadvantages, in addition to not being survivable, is bombers have long flight times from the United States. They're subsonic. They have low availability. The B-2 is a very fancy aircraft, but in fact, its average availability has only been 30%. And it's really uncertain in the long term whether a bomber could penetrate a sophisticated air defense. So that brings us to the ICBMs. And so this is what I would maintain and what former Secretary Bill Perry and others would maintain is the least essential leg of the triad, perhaps the one where we could afford not to replace this leg of the triad. So ICBMs have the advantage that they're always on alert. They have to be. They have to be ready to fire at a moment's notice because they are not survivable. They are vulnerable to a Russian first strike. They do offer a large number of aim points, these 400 silos. There's also a number of launch control, physically separate launch control centers where the crew sits to operate the missiles. They have, once you build them, once you spend the $100 billion or so to deploy them, they're the least expensive of the legs to operate and maintain. And if they're only armed with one warhead, they're not terribly attractive targets because the Russians would have to expend a warhead, at least one warhead, to destroy each missile because they're in hardened silos. And so, expending a warhead to destroy a warhead is not something that results in a net advantage at the end. But the main disadvantage is that ICBMs, when they're based in silos, cannot survive an attack. And for that reason, they're only usable if they're launched first or under attack. And both of those things strike many people as not wise. A first strike or launch on warning of a Russian attack. So just, to take a step back and talk about the basis of deterrence. And almost everyone in these discussions agrees that the goal of US policy should be deterrence and strategic stability. But strategic stability depends on having survivable forces on both sides. That's what, the reason that we are confident in our deterrence of a Russian attack is because we know we have forces that could survive any Russian attack and could deliver a devastating retaliation on Russia, and Russia knows that, and so Russia would never have any incentive to attack us, and vice versa. That we are deterred from attacking Russia by the knowledge that no matter what we did, there would be Russian forces that would survive a US attack sufficient to destroy the United States. Nevertheless, we have this ICBM force, and the way that the DoD thinks about the use of any military force is under the law of armed conflict, where the only legitimate use of force is in self-defense, and the only way you can defend yourself is by destroying forces on the other side. And we keep our ICBMs on alert, ready to be launched in a few minutes on warning of a Russian attack, satellites in geosynchronous orbit would detect the hot plumes of Russian ICBMs, of Russian missiles. That would give us warning of an attack and time to launch our ICBMs under warning. And the problem is that this forces a quick decision about the launch of our forces. And just in a few minutes, really, the president would only have less than 5 minutes. And is it ever smart to put a person in that situation where it also raises the possibility of launch on false warning? And this launch under attack is kind of pointless, because if the Russians have launched a massive attack against us, how will the launch of our missiles on warning protect us? If Russia had withheld any forces that were vulnerable, they would surely launch them when they saw us launching under attack. So my sort of bottom point is that as long as silo-based ICBMs exist, there has to be a launch on warning option, and that's really unwise. Now, people do offer arguments in favor of silo-based ICBMs. The old arguments about ICBMs being accurate or higher yield or more reliable, those are all overtaken by improvements in submarines and submarine weapons. The submarine force can do everything that the ICBM force can do, basically. So one claim is that the ICBMs can serve as a hedge against the vulnerability of submarines, but they really can't. And they can't because they could only be a deterrent if Russia was convinced that we were able and willing and ready and always would launch under attack, which is crazy, right? To base deterrence on launching under attack. The other argument in favor of ICBMs is that, well, if we didn't have them, Russia might be tempted to launch an attack against the small number of remaining aim points, the few air bases and sub bases and command and control. But you have to ask yourself, why would Russia launch such an attack knowing that hundreds of warheads remained on submarines invulnerable at sea, ready to launch a counterattack? Wouldn't it be better if you took those 400 ICBM warheads and put them in a place where they couldn't be attacked by the Russians on submarines? So I think the real issue is the survivability of command, control, and communications. If you can assure that, then it doesn't matter how many other aim points there are on the continental United States. If we are assured, and by extension Russia was assured, that we could always launch a retaliatory strike from our submarines, then they should be deterred from launching any nuclear attack against the United States. Now, I remember when I was growing up, there was this cigarette commercial. Maybe you remember. It was like, if you must smoke, smoke Tarkingtons or something. It was like this low tar, low nicotine cigarette. So if you must have ICBMs, I think there is a cheaper option and simpler option than rebuilding the entire force with a new missile, and that is to extend the life of the Minuteman missile, and to do that by reducing the size of the force. So one argument for why we can't keep the Minuteman going longer is there's a limited number of missiles, and every year we flight test 5 of them, and we destroy another 1 or 2, and so we are drawing the force down below 400, the number that are deployed, and so we need to build new ones. Well, we wouldn't need to build new ones if we decided we only needed 300 or 150. And then it is said, well, no, the lifetime, those missiles are reaching the end of their lifetime, but what I believe is the case is that the methods that the Air Force uses to determine the lifetime, what they call the service life of the missile, are very conservative. And they're conservative in 2 ways. First, it's a statistical process. They, every year, pull a motor out and they chop it in, they take like a guillotine and chop it, and then they measure the properties of the propellant. And I should have said first that an analysis is done of all the subsystems of the Minuteman, and an analysis of how these subsystems are behaving with age and when they would reach the end of their lifetime. And the limiting factor for Minuteman is the hardening of the propellant. And the concern is that as the propellant ages and gets harder, at some point it would crack on ignition. And of course, cracking on ignition would mean the flames would go out the side and the motor would explode. And this is a cartoon. I want to emphasize, these are not real data. Just a cartoon I drew. So here is the individual, so here might be the elasticity, the hardness of the propellant. And these might be individual data points about once a year. And everyone in this room probably has done regression analysis and has done some confidence interval. And that confidence interval is pretty big if you only have a handful of data points. And you project out the lifetime of the missile. And here might be your best estimate of the lifetime, because here's a failure threshold. This is the point where you think the propellant might crack on ignition when it gets that hard. But actually, this is a model calculation. This is not from experiment. So there's probably some uncertainty there, too. And they pick some lower confidence level, and they say, well, this is the service life of that motor. Now, the problem with that, doing it that way, is at that point, let's say this was a lower 95% confidence interval. When you reach this point, 95% of the missiles are good. But you're throwing them all away because you're doing this statistically. You don't know which of the motors are good, right? But if you could choose the 5 that were bad and keep the 95 that were good, then this would be a way of extending the lifetime of the missile, but that would require making these measurements on every motor. But that's something that I believe is possible because the Navy does it for the Trident missiles. So, whoops. And in fact, there is a program. So we used to have 1,000. I have one more minute of comment. We used to have 1,000 Minutemen, and after the Cold War, we retired 500 of those. And they are in storage in Arizona, and they're used for space launch and test objects. And recently, there have been motors launched that are 50 years old. They're perfectly fine. And if you go back and you use this model and you say, what's the probability that a 50-year-old motor would launch and it would just be fine? 0. So I think that's sort of a proof that the methods that were used to determine the service life are too conservative, and that we could develop methods that would allow the Minutemen to be extended. And with that, I will stop. And questions? Okay. Yes?
So just quickly, can you refresh our memory on what the propellant is on the Minuteman, please?
It's a solid propellant, and
Can't say.
I've read it a number of times. Dick, do you happen to remember which? It's a different propellant in every. I was talking about the first stage, which is of course, the biggest one and the one that has probably the shortest lifetime. But
There are other factors. If it's hydrazine, nobody likes having that.
oh no! It's a solid. It's a rubber-like propellant. Yes.
What role, if any, does missile defense play?
Oh. I think I'm being told that people should go to Mike's, or I could repeat your question if you want.
What role, if any, does missile defense play in modernization?
What role does any, if missile defense, play in the modernization? Not any direct role, because there's an indirect role, because in the long term, the Department of Defense is concerned that Russia might develop missile defenses that these nuclear forces will have to penetrate. Another indirect role is that Russia is very concerned about our missile defenses. And it's for that reason that Russia has said it's not interested in reducing its nuclear forces further. So if Russia were interested in further reductions, then we wouldn't need as large a modernization on our side in order to maintain parity. I should say that you may have heard a speech by President Putin a few months ago, 6 months ago, where he described a number of Russian modernizations, and all of those are related to our missile defense. They are justified. The development of hyperglide weapons, nuclear-powered cruise missiles underwater, in the air, all of that is related to Russian concerns about our missile defenses.
So it's like I feel like you mean like in the last 10 years, the political situation and the relations with Russia came very dramatically from being relatively good and Russia being non-missile democracy to now really not that anymore. And I was wondering like how does that affect? Around 10 years ago, it seemed pretty easy to believe, oh, maybe we're about to engage in further, more substantial arms action. Now it seems like that's happening in the near future.
So the question is, U.S.-Russian relationships have deteriorated so much that, hasn't that affected the prospects for nuclear arms control? And of course it has, but I think the important thing to emphasize is that regardless of all of the other disputes between Russia and the United States, we still have a very, very strong shared interest in avoiding nuclear war. And also in reducing the costs of avoiding a nuclear war, right? Maintaining the smallest nuclear force that is necessary for deterrence. Neither of us has an interest in wasting money on that, and certainly neither of us has an interest in increasing the risks of a nuclear conflict.
You discussed mainly Russia and the United States. How is the development in other countries influence?
Yes, I mean, there are several other countries that have nuclear weapons, but the size of the U.S. nuclear force and this modernization program are driven almost entirely by Russia. The Chinese nuclear force is much smaller, and of course the North Korean force is tiny. So this plan is really developed to deter Russia, and the others are sort of lesser included cases. Yes, in the back.
Sorry, this is sort of a question about your comment on the C3I and how that plays a role in determining whether we should have ICBMs or SLBNs. I'm curious, how does the reliability of the C3I interplay with the size of the force? Because I would imagine that if I was going to call you to launch and the call wasn't going to get through 50% of the time, I should have two of you.
I don't think there's a strong interaction between. Oh no, he was on a mic. That there's a strong interaction between the reliability of the command, control, and communication system and the size of the nuclear force. The most important thing is to have assurance and your adversary to believe that even after suffering a nuclear attack, you could order the launch of the surviving forces, regardless of how many there are. So it's more of a binary, a one or a zero. You want assurance that even after the worst nuclear attack that Russia could inflict on the United States, that we would have the ability to launch remaining forces regardless of where they were, on submarines or ICBMs or bombers.
Thank you.